Welcome to Ask and Learn.
Okay, so here we're showing that Jan satisfies a recurrence relation, and it splits it up into whether we have an even number of players or an odd number of players. So we start with the even number of players, which is j of 2n, and we want to show that it's equal to 2 times j of n minus 1. So imagine we have an even number of players, right? So I'll just sort of draw 6 of them for show. And when the first thing that happens is we eliminate all the even numbered players, right? So we first would get rid of the person, and the second person, and then the fourth person, and the sixth person. And so one thing to note is that we have exactly half the remaining players. When we started with 2n, all right, so after one lapse around the circle, we take half of that. We are left with n players. Okay, if we were to re-index them, right, so let's say the second round we want to give them index 1, 2, 3, and say this is index I. Okay, well then, you note that to get its original index, you would take 2i minus 1. Right, so 2 times 1 is 2 minus 1 gives me 1. 2 times 2 is 4 minus 1 gives me 3. 2 times 3 is 6 minus 1 gives me 5. Okay. And so if we presume, and this is just 6, but this could go up to any, this is up to 2n players, we know that our survivor is j of n, right? That's sort of determined by that function. So whatever index our survivor is at here is index I, right? So this formula, then we just plug j of n into I for whatever that player is, right? So that means that this is going to be equal to 2 times jn minus 1. Okay, and that's exactly what we needed to show for the case where we have an even number of players. And so now we consider when there is an odd number of players, and that we are going to represent as 2n plus 1. Okay, so when we have the odd number of players, so let's just draw 7 to show we kill off, right, the even ones first. And then we always end up looping around and in the next round killing the first person every time. Okay? So now once we have done this, we are left with half the number of players, right? So we again are left with n players. Okay, and our new indexes, so it would have been 1, 2, 3, 4, so on. Ends up being that 3 becomes 1, and 5 becomes 2, and 7 becomes 3. Okay, so maybe we should have written those down. 5 and then 7 there. Okay, so if we give them the new indexes, well, that is represented by 2i plus 1, right? So if we take 2 times 1, we add 1, we get 3. 2 times 2 plus 1 is 5, and so on. And whatever index our j of n is at, we'll then put into here, right? Because these indexes are the indexes for when we just have n players rather than 2n plus 1. So we'll put j of n in for the ith case, and that'll give us that this is equal to 2 times j of n plus 1. Okay, and then it also wants us to show this base case, right? The j of 1 instance. Okay, well, we have j of 1, we have one person. And there's, you skip the first person and you would eliminate the second, but there is no second. So you have one person in one position and they must be the only survivor.